In the truck trailer question, just going to give you a similar example to what we did last year. There's a road here, and there's some sort of truck pulling in that direction. And then we had one trailer here, and we had another trailer here. And we're only going to go North America. In Australia, apparently, they have 3 trailers. Never been there yet, but they're big trains of trailers. So they're full-size trailers, apparently, just like we've got right here, but instead of just 2, there's one more back here. Just going to put the tires in. This will work on so many different examples, but obviously this will transfer over to trains as well. And instead of some sort of hitch between the trailers here, it would be just the hitches between the train cars. Okay, so there is some sort of hitch right here. Could be a cable if it's a tow rope between 2 cars. And I need to actually tell you what the truck pull is, so the F pull, and it's getting pulled this way, okay? I'm not going to give you any information on the truck, it just complicates the matter. But the fact is you get something pulling here with a force, and then there's friction. So there's a force of friction right here, and another force of friction right here on the other trailer. In fact, if I call this trailer 1, and this one trailer 2, this is force of friction trailer 1. This one's force of friction on trailer 2. And I need to give you some masses of the trailers.
Would it be pointing the other way?
The force of friction?
Yeah.
Yes. No kidding. Thank you. They can't be in the same direction as the motion. Thanks, Nick. Force of friction goes back that way. I'll clean up my diagram. Keen eye. The only way that force of friction could go in that direction is if it was stopping, I guess. Like if this truck was going full speed and they were stopping, then the friction would have to go in the opposite direction to the motion, I think. Anyway, as it's drawn right now, absolutely like this. Okay, so we got force of friction 2, force of friction 1. We also have some weights right here. Weight of trailer 1 and weight of trailer 2. And then, of course, to offset those, there's Fn, the normal force, on trailer 2, and Fn on trailer number 1, normal force of trailer number 1. And I think that's it. That's all the forces that I can think of that are acting on those trailers. We'll worry about this force in the hitch later. But this question would always be, A, what is the acceleration of the trailers? The trailers are hitched together, so you have to consider them together, okay? So you wouldn't pull them apart. But for B, though, you'd have to pull them apart because it would ask, what is the tension force in the hitch? So it could be a hitch, it could be a cable, but whether it's a cable or a hitch or whether it's a rope or something, you could actually calculate what that tension is. And for people who move on into first year university, you have to know how to do this. And for people who are moving into engineering, these are problems that you're going to encounter all the time. So there is a force in here, even though we're not considering it right now, because the two things are stuck together when they're accelerating. There really is a force there. And we'll calculate what that is. Okay, so moving on quickly. Pretty easy math, and in fact we've done A last year. You just have to go F net is equal to M of both times A. So to answer this one, F net, the net force, is equal to mass of both, because both trailers are stuck together, times A. If it was Australia, you'd go mass of all three of them times A. The winning force is the truck pull. It's the F pull. So F pull would be the winning force. The losing force, there's two of them. Force of friction 1 and also force of friction 2. So there's two losing forces. Is equal to mass of both times A. I need to give you some numbers. The truck. M1. Hi. Oh, good. Thank you. M1, let's say, is 1,000 kilograms. Let's say M2 is, for the sake of argument, 1,100 kilograms. And let's say F pull. Just have to do some mental math here. I'm going to say that mu, coefficient of friction, is equal to 0.10, just for round numbers. And I just want to make sure that that's strong enough force. The F pull, I will say, is 3,000 newtons. So right here, 3,000 newtons. Okay. There is no slope. There's no one pushing the trailers down or lifting the trailers up. So to get the force of friction, it's just like last year. Force of friction is mu times the weight, okay. So this one, force of friction 1, is just mu, coefficient of friction, times the weight of 1. And force of friction 2 is just mu times weight 2. Those are your two losing forces, F pull and equals mass of both times A. I'm just going to put numbers in now too. So F pull was 3,000. Coefficient of friction was 0.10 times weight. And weight is mass times gravity. So it's 1,000 times 9.8 plus the other losing force, which is 0.10 times 1,100 times 9.8, is equal to mass of both of them, which is 1,000 plus 1,100 times A. So we've got one equation, one unknown. Carefully go through and calculate what that is, okay? And I'll do this. Anyone got it yet? Nice. So do your algebra right, finish this side off here, divide by 2100. And could you go one more digit? 0.4
448.
440. Okay. And then we'll round up to 2. Okay. Thanks. Okay, so we got it to 3 digits. Your answer really would be only to 2, because probably 0.10 is 2 significant digits. 3,000, don't know. It could be 4 digits or it could be 1. And 1100 is maybe 2 digits, or it could be 4. So chances are it's only accurate to 2 digits. So if you reported this as 0.45, great. But for the sake of the next calculation, don't round up too early. We're going to need this to 3 digits, okay? I don't care whether you report it to 0.449 or 0.45. But it wouldn't be 0.5, wouldn't be 0.4. And it wouldn't be like 4 or 5 or 8 significant digits. So you would only have an answer that's accurate to 3 or 2. And for this course, really, if you round up to 3 or 2 digits, I'm happy with that. Because we're not going to have accuracy more than that. I won't give you numbers that are more accurate than that. Okay, last part. It's the easy part. B. Find the tension in the hitch. To find the tension in the hitch, as we talked about last year, if I really needed to find this between 2 trailers, I should really pull the hitch apart and attach some sort of scale right in here and then reattach the hitch. So you'd have a scale that could get pulled outward and you would measure what that tension force is. And we can't do that. We don't even have a scale that could do that. And this is just a theoretical question. It's a math question. But mathematically, there is a way to cut this hitch and put in a scale. And it's this way. And I don't know whether we did this last year or not, but this is the way you would do it. I could just pick one trailer. And you mathematically break the hitch, and that's what we'll do. So we'll actually cut the hitch. We'll look at trailer number 2 and we'll break it apart from trailer number 1. So here's trailer number 2. I'm trying to find this tension force right here. That one. So by mathematically snipping that hitch, I can have just tension right here. Everything else doesn't matter. And the only other forces acting on trailer 2 are this, force of friction 2, and that is it. It's got the weight down and the normal force up, of course. But they don't affect the motion, because the motion is left-right. So there's only one winning force, it's tension. There's only one losing force, it's force of friction 2. Okay? So here we go. F net. I mathematically cut the trailers apart to find the tension. So I really only consider one trailer. It's mass 2 times A. The winning force is tension. The losing force is force of friction 2. The mass 2 is whatever it is, times the A that we just got, 0.449. So we're looking for tension. Force of friction 2 was 1078. We got it before. I left it up here. Mass 2, 1100, times the acceleration we just got, 0.449. So you got one equation, one unknown. You can find out what your tension is. And if you could just let me know what that is, that would be great. Anyone got it yet? Anyone else too? 1571? Nice. 1572, right? And to round up, really, if we're only accurate to 2 digits, this could be 1.57 times 10 to the 3 or 1.6. But it's really only accurate to 3 digits at the most. So 1, 2, 3 newtons. Or 1.6 times 10 to the 3 newtons. So that's your final reported answer. That's if we consider trailer number 2. So this was trailer 2 only. I have to verify my answer. So this is the last of the math that we have to do today, up on the overhead anyway. I want to find the tension by using trailer number 1. It should be the same. And that's because of Newton's third law. For every force, there's an equal and opposite force. So we better get the same answer. If we don't, we know we've done something wrong mathematically. So again, it'll be fairly quick now. This is trailer 1 only. So I've mathematically cut the hitch, and I'm going to look at the force in the hitch, which is called the tension. So here is trailer number 1. It has force normal 1, weight 1, which has nothing to do with the motion, except that the weight makes the force of friction. But in the direction of motion, we got force of friction 1, and we've got the tension. Tension is going back this way this time. It's equal and opposite, it should be, to the tension right here. And then we got one more force acting on this trailer, and this is the F of the pull from the truck. F of the pull we had from last time, it was 3,000. So here we go. We'll do the same thing, F net equals M1 times A. And you'll see that the answer is exactly the same. Winning force is F pull. Losing force, there's 2 of them. There's tension and force of friction 1 is equal to M1 times A. Just going to lift it up. The moment of truth. F pull is 3,000. Tension, don't know yet. Watch the negative sign. It goes for the force of friction. Minus the force of friction. Was 980 is equal to 1,000 times the acceleration that we calculated already, which was 0.449. So just to clean it up a bit, 3,000, all the numbers on one side, minus 980, minus 1,000 times 0.449 is equal to T. If that number isn't 1572, I'd be really surprised. Check it out though, see if it is. Nice. 1571?
Yeah.
So it is accurate to only 3 significant figures. Okay, the other one, 1572, this one's 1571. So you really can only report it as 1.57 times 10 to the 3. That's as accurate as it is. And that's it.